So if we have the parametric equation, x equals t squared plus 1, y equals 4 square root of t, and z equals e to the t squared minus t. Let's figure out, if this is a parametric equation for a curve, let's figure out what line is tangent to this curve at the point 2, 4, 1. So what does this mean? It means we have this parametric equation. Let's illustrate with an example of what this may look like. So let's say we have this curve, and we won't use the z-axis just for simplicity, and this is just a random curve, but this just gives the idea. So what this parametric equation is saying is that at each t, we're gonna get a different coordinate point. So it's t equals 0, we're gonna have x equals 1, y equals 0, e equals 1, if you do the math. At t equals 1, we'll have a different set of coordinates. And so what we want to do is figure out when we are at the point 2, 4, 1 in this parametric equation, what line is tangent to the curve. So how do we do this? So first we have to figure out what t is at that point, 2, 4, 1. When we're at the coordinates 2, 4, 1, what is t? So how do we do that? Well, we could set these equations up. We have 3 equations. So when x is 2, we have t squared plus 1. We have 1 equals t squared. 1 equals absolute value of t. So t could be positive 1, negative 1. And for this part, for our y component, we have 4 equals 4 square root of t. 1 equals square root of t. 1 equals t. So we know that 1 equals t. We can confirm with our z. We have 1 equals e to the t squared minus t. And when t is 1, then we're going to get e to the 0, which is 1. If t is negative 1, we're going to get e to the 1 minus plus 1, which is going to give us e squared, which is not 1. So we know it's positive 1. So we have our t. Now what do we do? Well, we know that the equation, parametric equation for the line, is going to be, we're going to have our t function, the vector function, equals rt initial plus t v. This is v is a vector, direction vector here. So we already know initially we're going to have 2, 4, 1, because we want to point to that initial point. And then we're going to have t, and then what is v going to be? How are we going to get v? In order to get v, we need to know the direction that it's going. If we're pointing here, is this the initial point? We want to know what direction we have to go as we scale t. And so how do we get that direction, v? Well, if we differentiate x, y, and z, we can get each component of the direction at the specific time we want, t equals 1. So let's do it. So we have dx over dt is going to equal 2t. When t equals 1, when t equals, t equals 1, we have 2. dy over dt, t equals 1, we have, let's differentiate first. So if we differentiate, we have 2 over the square root of t. Because we have 1/2, we drop that down, it's 2, goes to 1/2, the negative 1/2 goes to the bottom. And then when t equals 4, we have 2 over 2, so it's 1. dz over dt, we have e well, let's differentiate that first. So we have to take the derivative of the exponent, 2t minus 1, and then we still have everything that's up there. So you can see that. And so when t equals 1, we're going to have 1 here times e to the 0. So we're going to have 1. So we have 2, 1, 1. That's our each component, our direction vector. So we can write that 2, 1, 1. So this means that we have basically this first component here, the initial component, is going to be whatever vector that's going to point somewhere. And then we have a direction vector that's going to point in another direction, but it's going to scale by a t. So it's going to scale by t, and it's supposed to be a straight line. And so the actual function or line that we get is not this vector. This vector just points to the initial point. That's a key point. So what we're going to get is, this will be initial. So when t equals 0, we have 2, 4, 1. We're starting at this point. When t equals 1, we're going to add 2 to this. We're going to add 1 to 4. We're going to add 1 to 1. So it's going to go in that whatever direction it's going to go in. And we're going to get different coordinate points for each t. These are the different coordinate points we're getting. Notice this is not the coordinate points we're getting. This is just pointing to where we start. And these aren't the actual coordinate points. This is just pointing in the direction we're going, so that we can get coordinates. This whole thing gives us coordinates with different t's. It's a good thing to keep in mind. And so when t equals 0, it just happens to be this as a coordinate, even though this is a vector, right? Because it points here. So if we take this and put what it equals, we have 2t plus 2, and then we're going to have t plus 4, and we're going to have t plus 1. And so if we want to write it in the format up here, we have our x equals 2t plus 2, y equals t plus 4, z equals t plus 1. There we go.